When I measure a liquid in a graduated cylinder, how many digits do I record? How certain should I be about the value I record? The equipment we use to measure things is not infinitely accurate. There is some degree of uncertainty with any measurement. We communicate our level of certainty by reporting our measurements with the proper number of significant figures. Each digit present in a number is considered a significant figure, except zeros in certain situations. More on that later. The number of significant figures of a measurement is dictated by the smallest increments that instrument measures to, plus one estimated digit. This cylinder has markings every 1 milliliter. I can see that the meniscus is above 33 but below 34. So I'll record 33 and then estimate the last digit. That looks like about 33.6. It would be dishonest of me to record 33.65 or even 33.60. because that implies a degree of accuracy that this cylinder does not have. Let's take a look at a balance. I tared this balance earlier, so I'm just looking at the mass of the water inside the cylinder. We consider every digit the balance shows significant. That's why the top-loading balance, a less accurate instrument, has fewer digits than the analytical balance. Here I can see my 33.6 milliliters has a mass of 33.6160. I want to know the density, so I'll divide my mass by my volume. I still need to report my density with the correct significant figures. The calculator will list as many decimal places as it can, but that doesn't mean they're significant. We'll talk more about sig-fig rules and calculations, but in this case, since my volume only had 3 significant figures, my density can only have 3 as well.
Here are the rules for significant figures. Non-zero digits are always significant. Zeros are significant if they lie between other digits, they're trailing a decimal after other digits, or if they're trailing a decimal after some non-zero digits. Zeros are not significant if they are leading zeros, or if they are trailing zeros in an integer without a decimal point. You can view all these rules and practice identifying significant figures in your manual. We also have some rules for propagating uncertainty in calculations. In multiplication or division, the result should have the same number of significant figures as whichever factor had the fewest significant figures. In addition or subtraction, the result should have the same number of decimal places as the value with the fewest decimal places. We should also keep in mind that exact values, like conversion ratios, have infinite significant figures. Once we've figured out how many significant figures the result of a calculation should have, we simply round to the nearest significant figure. Let's work this example problem. An empty beaker has a mass of 33.34 grams. A student adds 0.01000 liters of liquid to the beaker and determines the mass of the beaker with the liquid is 37.8495 grams. What is the density of the liquid? Report your answer with correct significant figures and standard units, grams per milliliter. I'll start by determining the mass of the liquid. I just have to take the mass of the beaker and liquid and subtract the mass of the empty beaker to get 4.5095 grams. As written, this value has 5 significant figures, but I need to recall my calculation rules. Since one of the values in this calculation only had 2 decimal places, that means my answer can only have 2 decimal places. I can still use these excess numbers in further calculations before reporting my final value. So I'll just use a line to mark where the last sig fig is. This number should have 3 significant figures overall. Now to find density, I'll simply divide the mass by the volume. I have my mass in grams and my volume in liters. Since I'm shooting for units of grams per milliliter, I'll have to convert that liter to milliliter. The units of liters cancel out and I'm left with grams per milliliter, and that calculation comes out to 0.45095 grams per milliliter. If I look at the factors that went into this calculation, I see one of my numbers had 3 significant figures, and one of them had 4 significant figures. So my result must have 3 significant figures. If I round to the nearest sig fig, my density is then 0.451 grams per milliliter. In chemistry, you'll perform many multi-step calculations, so it's always important to propagate the error and keep track of your sig figs throughout.